As we continue on our lecture about area computations, we discuss another method which is called area by DPD method. The DPD method is very similar to the DMT method as both are equally precise and offer easy calculation of the area of any given tract of land. DPD refers to the double parallel distance, and the double parallel distance is defined as twice the distance of the midpoint of the course from the reference parallel meridian. So for any given course, supposing that this is your course AB, and we have the reference parallel meridian, which is actually the east-west line, we first identify the midpoint of the course and call it as M. Project this onto our parallel meridian at point M prime. The double parallel distance of line AB is simply 2 times the distance MM prime. Recall that for the double meridian distance, we project M onto our reference meridian, which is the north-south line, and we project this onto that line. Let us refer to this point as M double prime. And we know that the DMT of line AB is equal to 2 times the distance MM double prime. And from this, we can calculate the so-called double area. We say that the double area using the DPD method will be equal to the product of the DPD of the course multiplied by the adjusted latitude, or rather adjusted departure of the course. Using the DMD method, we know that the double area is equal to DMD times the adjusted latitude. Let us now calculate the DPD of the courses comprising a traverse. 1. The double parallel distance of the first course is equal to the latitude of the course. Second, the DPD of each of the other succeeding courses is equal to the DPD of the preceding course plus the latitude of the preceding course plus the latitude of the course itself. Finally, the double parallel distance of the last course in a traverse is always equal to the negative of the latitude of that course. So for example, we have a traverse, a closed traverse, where the corner points are A, B, C, and D. Let us draw our parallel reference meridian. For the first course AB, it will be the projection of the midpoint of line AB onto our reference meridian, reference parallel meridian. We denote the points as MM prime, and twice that distance is the double parallel distance of line AB, which is equal to the latitude of line AB. For the succeeding courses BC, CD, and DA, the DPD of BC will be equal to the DPD of the preceding line AB plus the latitude of the preceding line AB plus the latitude of the line BC. We apply the same rule for side CD. The DPD of CD is equal to the DPD of the preceding line BC together with the latitude of BC and the latitude of CD itself. And finally, the DPD of the last line DA is equal to the double parallel distance of the preceding line CD plus the latitude of CD and the latitude of DA. And according to our third rule, the DPD of the last course is equal to the negative of the latitude of that course. So in other words, if our calculations are such that the computed latitude or the computed DPD of the last DA is equal to the negative of the latitude of DA, then we have the correct set of values for the DPDs of the courses comprising our traverse. And we can proceed in calculating the double areas as well as the area of the entire tract of land. Let us now solve the following problem. The following table gives the adjusted latitudes and departures of a closed traverse. We calculate the area using the DPD method. The first step is to calculate the double parallel distance of each course. So we have here the adjusted latitudes of the courses comprising our traverse. We start with line AB. The DPD of line AB is equal to the latitude of the line itself, being the first course. Then we proceed to the next. The DPD of BC will be equal to the DPD of the preceding line AB plus the latitude of that line plus the latitude of line BC. We apply the same formula or rule for the next line CD. So the DPD of line CD will be equal to the DPD of BC plus the latitude of BC plus the latitude of CD. And that is equal to 1828.25. Next, for line DE, the DPD of line DE is DPD of CD plus latitude of CD plus latitude of DE equal to 498.08. Next, for line EF, the DPD of line EF is equal to the DPD of DE, latitude of DE, and latitude of EF equal to negative 627.35. Finally, for the last line FA, the DPD is equal to DPD of EF, latitude of EF, and latitude of FA, which is equal to negative 375.01, and that is the negative of the latitude of FA, indicative that we have the correct values of the DPDs for the different traverse lines. And we can proceed to the next step of calculating the area. We proceed to the next step in our computation by calculating the double areas. So we have here the table indicating the lines, the adjusted latitudes and departures, and the corresponding DPDs of the courses. So we start with the double area of the first line, AB. The DPD multiplied to the adjusted departure of line AB gives us the double area, which is 23,195.86. We do the same thing for all the other lines. So the double area for line BC will be DPD of 1,568.54 times 608, or rather 609.89, which is equal to 995,068.32. Next, the double area of CD is 1,828.25 times 786.78 equal to 143,008, or rather 1,438,430.54. The double area of line DE is 498.08 times 218.32 equal to 108,740.83. The double area of line EF is negative 627.35 times negative 1,116.62, which is equal to positive 700,511.56. Next, for line FA, the double area is equal to negative 375.01 times negative 544.64 equal to 204,245.45. Observe that all the double areas are positive. So the next step is, of course, to add up all the double areas. So we add 23,195.86, 995,068.32, down to 204,245.45, and the sum is 3,430,192.56. Being a double area, we divide this by 2 to get the area of the track. So dividing the double area by 2, we'll be getting an area of 1,715,096.28 square meters. In the event that the summation of the double areas is negative, that poses no problem. We just have to take its absolute value. The following table summarizes the results of our computations. So observe that our area is the same as the one that we have obtained using the DMD, or the double meridian distance method. Thanks for listening.